Paper ID 37. Hello.
Yeah, hello.
Yeah. So
Okay.
you can share your paper. Okay.
Okay.
Nikhil Rane. You can on your camera better. Yes, you can start. Okay. Make it full screen and start.
Is it visible in full screen?
Yes,
Yes. Visible.
So I'll start.
yes, go ahead.
Okay. So hello everyone. Myself is Rani from Vishwakarma Institute of Technology, Pune. I'm studying final year ENTC. So I will be presenting a paper titled Anomalous Behavior Detection in Surveillance Cameras using Optical Flow Algorithm. Coming to the abstract of the paper, our research focused on making public spaces safer by using advanced technologies to detect suspicious behaviors like fights. What's unique about our work is that we combined different techniques like optical flow, background subtraction, along with the support vector machines classifier to detect unusual events in surveillance videos. So we have achieved mean AUC of 92% along with strong accuracy of 86% with our system. Like we can use these tools for law enforcement to spot and prevent crimes, ultimately improving the public security. So the next up is introduction. There are challenges in traditional methods for detection of fights. In traditional methods, like imagine having to watch countless hours of surveillance videos manually. It's not only impractical but also prone to errors. This makes it really tough for human operators to spot and respond to incidents that they happen as they happen. Okay. This is where the automated methods come in. Leveraging computer vision and machine learning technologies, it have become an essential part to detect such behaviors and ensure this public safety very effectively. So now let's understand a key technique we use, that is optical flow. It's a computer vision technology that calculates how objects or features move between consecutive video frames. Think of it as tracking a shifting pixel in image. This gives us very valuable insights into motion and direction of the objects moving in the video. When something unusual happens, optical flow technology captures sudden and erratic motions. This is a big clue that something might be off. Okay, and it makes our system really good at spotting anomalies in public spaces, which is very crucial for keeping people safe. Moving to the methodology, the traditional core methodology is based on optical flow based magnitude thresholding, where the use of Gunnar-Farnbach optical flow algorithm from OpenCV library is utilized. Then here we calculate the motion of pixel between consecutive frames, effectively capturing the movements within the video. The features are extracted then to transform into flow magnitudes. That means the intensity of displacement in the consecutive frames. We then compute the mean magnitude of these features, which serves as crucial thresholds. If this feature magnitude surpasses the threshold, we classify the videos as abnormal. So where in this paper, the main focus is on this methodology, which utilizes background subtraction and support vector machines to classify the results. So we begin with adapting the UCF crime dataset to create. Just a second. We utilize the. We begin with adapting the UCF crime dataset to create more focused dataset containing 30 frames videos of both fight as well as normal activities. To isolate these moving isolate this moving object in videos, we use the combined difference image method. This technique subtracts the background, helping us to identify objects in the motion. Then from these background subtracted features, videos, subtracted crucial features like gray, canny edges, Harris and Laplacian filters, optical flow and optical magnitudes, and Euler. Extracted features were then aggregated and fed into two-class SVM with RBF kernel to optimize this. SVM's performance, we conducted hyperparameter tuning using grid search CV. And to ensure the reliability of our classifier, we perform five-fold cross-validation using stratified k-fold. After training SVM model, various features, like we would use hard voting classifier to make the classifying decision, to make a final classification decision. And this classifier also aggregates the output of all the results and hence the final output. Have a look at the pre-processed feature set extracted from video data using various filters and background subtraction techniques. For example, after applying background subtraction and then using the Harris filter on that frame, we computed these these features, these values, which are computed using pixel-wise NumPy addition on that current frame. Here the final dataset for this process contained 247 videos for training, along with which each of which have containing 0 to 27 frames. That is 28 frames in total for all the videos. This visual represents the output of Farnbach optical flow algorithm. To make it more visually understandable, we have used the markers to represent both the magnitude as well as the direction. Okay. Have a look at this HSV representation for better understanding. This represents the flow in the form of heat map. To gain more comprehensive understanding, you can these examples showcase the videos that have been successfully classified as normal and abnormal. This is the normal version. This is the abnormal version. This is the normal version. Moving further, next is a performance metrics used for evaluation of this model. Our ROC's mean area under curvature score averaged an impressive 92% with standard deviation of 5%. We also attained accuracy rate of 86%. But here AUC is the primary metric, as it better quantifies our model's ability to distinguish between normal and abnormal behavior, which is crucial for this research. So to conclude, we implemented various methods like optical flow, background subtraction, and support vector machines to make detecting fights in surveillance video more effective. And talking about benefits of our approach, it can be used for use as public safety, traffic monitoring, and security surveillance. Also, it's also got insight that researchers and law enforcement can find handy. To improve this system further, our aim for future research is to explore deep learning algorithms and add audio-visual features, then create real-time applications, test on various datasets, and investigate transfer learning for better accuracy. So overall, progress in video-based abnormal behavior detection can significantly boost public safety in various diverse environments. These are some of the references we use for our research. Thank you. Any questions?
Well, Nikhil, good. You have done a good experimentation.
Yeah, thank you.
When was the optical flow algorithm was introduced?
Yeah, the optical flow algorithm was introduced at a very early stage of the computer vision era. which was around 2000s. So there are these two algorithms mainly used. That is Lucas Canade, which focuses on only the key points on the videos and then track those key points. And the second algorithm was lately discovered, I think, in around 2002, which was a Gunnar Farnbach algorithm, which focuses on entire pixels of the frames and calculate the displacement of the calculated points that are moving or displacements.
So then, what was the application that was there for this algorithm in the area of video surveillance earlier?
Yeah, the area of this algorithm focus on mainly detection of the motion tracking, object tracking. But there are features. When we did during our research, when we did feature engineering, we came across the features that we extracted that correlated with tracking of these fights. So we first our approach was to do the general suspicious detection, suspicious activity detection, but we focused on this fight detection area as the data set was also there, and our technique of using only core machine learning was better suited for this approach.
Okay, so then if you want to compare your this optical based algorithm with the machine learning based algorithm, then which will work better according to you?
Yeah, currently there are many significant improvements in the field of this
CNN and all deep learning.
Yeah. In deep learning phase, in deep learning area, there are many significant improvements. Like there are better accuracy, but we focused on mainly doing this project in core machine learning using support vector machines.
Yeah, that's correct. The basic things are very fine. My question is, like, say, can we have a combination of this optical flow with the CNN? Then how it will improve the accuracy or the results quality?
First of all, it will significantly reduce time to do the feature engineering, as we can pass directly the convolution and pooling layers, which can extract all these features for us, and it will automatically understand what the videos are and how to detect those anomalies. And also there are algorithms already in this field that are giving significant results.
Okay. Can you go to the result and can you explain any one table, just one table? Any one table. You have shown one slide on that.
Yeah, this one, right?
Yes.
Okay, so for the post processing of our data set, which we use for
one reading, you need to explain. Let's say Harris and number 1 in that.
Okay, so our data set contain a total of 247 videos, and then these feature, that is 35, 60, 310. These are the NumPy addition value of the image pixels when we background subtract image and then apply the Harris corner feature. Then there are certain pixels on that image that are those pixel values are total added as a NumPy addition, and those values per frame are noted here. Like for the 0th frame of the 0th video, this value is there. First frame of the 0th video is this. Like this, there are 28 frames in every video in our data set, and such like this Harris, Laplacian, Euler, optical angles, optical magnitude, these features are extracted, and then we pass them to SVM and then hard-coded classifier.
One more thing, like say on one side there are 28 videos. On the vertical side there are 0 to 246. What is that?
0 to 246 means these are the number of videos. Total we have used 247. Yeah.
And then based on this, you are, I think, summing them and then putting them in a 2 class.
Yeah, there are 2 classes, which are 0 means it denotes the that is the video is normal, and one which denotes the video is abnormal.
But based on what?
We have manually curated the data set, and We have manually curated the dataset after post processing, and for all those 247 videos, only the part of feature engineering was to get these values, these numpy added values.
Okay. Okay. Thank you.
Yeah. Any more question?
So from my side, only one question. Actually, already there is a lot of research work on suspicious detection from the what is that videos and so
Yeah.
can you please tell in one or two statements how your work is different from the existing work?
Okay, so my work is it focuses on applying applying background subtraction, and using all those computer vision key features, key techniques like Harris corner detection, Laplacian filters, and all those. And after that, using some hyperparameter tuning and using a support vector machine. This algorithm was we have. I'm like studying in. I was studying in third year, and this paper was actually a part of computer vision subject. So all those key technologies I've tried to implement in this research.
No, everyone is using whatever you are telling. Everyone is using same thing. So
No. Actually, everyone was doing the threshold part where the magnitude and angles were calculated. This part was the traditional part, and this part was our key methodology where we use the different types of feature extraction techniques and then train the model on SVM.
okay, same thing you are repeating. Okay, just to work out on this one. Okay.
Yeah. So thank you so much, paper ID 37. So next, I would like to call paper ID 22.